Okay, let's have fun with the moon again. And let's do the inverse square law and make it real easy to understand.
Have you ever walked around in the dark with a torch and discovered that if you shine the torch close to your feet, the ground appears quite bright? But as soon as you shine your torch at a further distance, the amount of light that you get is significantly less.
Here's a simple studio light to give you an idea. So here's a diagram. Now, if you look at a diagram at 2 feet, like double the distance, you lose 75% of your intensity, your luminosity. And when you go 10 feet, you lose 99% of its luminosity. So light diminishes pretty quickly. So here we are on a full moon, and look how bright that thing is. Now, I'm between bushes, so no other light from the area can shine in, just the moonlight. Now, we're going to be using foot candles. So I'm going to try to do this film and hold the light meter. And chew gum at the same time. Okay, here we are, 0.02. 0.02. So for fun, I looked it up, and I have the same number as the Meteorological Society. Okay, so let's set up our scale again. And right here, we're going to put 0.02, because that's the light of the moon on Earth. And then our moon, we're going to set it up here. And then we don't know the brightness of the moon, so we're going to have to set up some kind of baseline to figure it out. However, we do know the alleged distance to the moon, which is around 1.2 billion feet, and the diameter, which is a little over 2,000 miles. So we're going to set up our baseline. So we got a real bright light downrange, and we're going to get it to 0.02. So we're getting close here. So I'm going to move up a little bit more, and we got 0.02. Okay, let's see how many feet we are from the light. We have a tape measure down here. It's pitch black out here. All right, so if I can read it. 167 and a half. So, and it's a little bit left of that, so we're going to call it 168. So our light is 168 feet away, and it gives off 0.02 lumens, just like the moon. Okay, let's have a little fun with the inverse square law so you can see that it works. Okay, so let's cruise up towards our light here, and I put 2 blocks of wood on the ground. Now, you can pick any 2 distances you want. In this case, I'm just taking a number and then divide it in half. So you're going to divide it by 2. So you divide it by 2, and then you square it. So 2 times 2 is 4. So we're going to look at these 2 numbers here, and we're going to divide it by 2, and then we're going to square it. So 2 times 2 is 4. 4 times whatever this number is. So let's take a look. Okay, we're at 33 feet, and we got 2.49. Okay, so we're going to times that by 4. And then we're going to cruise up. Now we're going to go half the distance. Divide the distance by 2, which is 16 and a half feet. I guess I'm going to have to show it to you here, 16 and a half feet. You can see how it lines up with a piece of wood. Okay, so this should be around 10. Let's see what it is. 9.94. Pretty awesome. Okay, now let's see how bright the bulb is. So now it's so bright that it killed the meter. So let me try to get it closer here and take a look at it. So, you can see you've got 36, 35. Let me try it again. We got, it's hard to see it, 30, 29, and then 31, 33, 3,600. Now remember, these are foot candles, so you have to times it by 10.7 to get lumens. The factory specs on this light bulb is 36,000 lumens. So that's equivalent to about 3,400 foot candles. So you can see like we're right in there. So let's use the factory spec at 36,000 lumens. So let's go back over here at 168 feet at 0.02 lumens. Now what happens if we add a light? So we're going to double the light, so we got to square that. So you got 2 times 2 is 4. Now 4 times 0.02 would be 0.08. So let's see what we get. Okay, we added another light, and let's see what we got. 0.07. Pretty close. Not bad. Should be 0.08. Okay, so what if we put 3 lights down there? So we're going to be adding 2 more. So we're going to triple the power. Now we want to square that. So 3 times 3 is 9. 9 times 0.02 is 0.18. So we should have 0.18. There's 3 lights down there. And let's see what we have now. 18. Right on the money. Wow. Okay, so obviously the inverse square law works. So we go back to our scale, and now we're going to use 36,000 lumens. But first we have to divide the distance by 168 feet. And then we're going to square it. So the moon is 238,000 miles away. We're going to times it by 5,280. Then we're going to get 1.2 billion feet. Now we're going to divide that by 168 feet. So we got 7.4 million. Now we got to square that. So we're going to times it by itself. 748,000. Okay, so this is what it is squared. 55 quadrillion. Now we're going to take that and times it by the lumens. 36,000 lumens. So it's the moon is 2 quadrillion or quintillion or gazillion lumens.
Now I am become death, the destroyer of worlds.
The moon is 2 quintillion lumens. Let's look at it in another way. Let's take the surface area of the moon and turn it into square feet. First, let's drop our number into our super big calculator so we don't lose it. So the way you figure out the surface area of a sphere is pretty easy, easier than I thought anyway. It's 4 times pi r squared. So now let's figure out the surface area of the moon in square feet. So we have the radius right here. We're now 1078. That's miles. So we're going to times it by 5,280. And this is going to be feet. So now we got to square that. Radius times radius squared. 5,691,840. So that's the radius squared. So now we're going to times it by 4. And then we're going to times it by pi. 3.1415. So that's our total square footage, surface area of the moon in square feet. So now that's the whole moon. So now we got to divide it in half because you're only looking at half the moon divided by 2. Here's our number. This is square footage of half the moon. We're going to copy it. We're back to our big calculator. Now the top number we put it back in. That's how many lumens the moon is. Now we're going to divide it by the square feet of half the moon. Paste it. Here's our divide button right here. So it's 9895, 10,000, almost 10,000 lumens per square foot. That's a lot of light. So let me show you how bright that is. So let's go back to our 3 light setup right here. Now those 3 lights have 100,000 lumens. So let's put a 10 by 10 box around them, which is easy to figure out because the garage door behind it is 10 by 12. So 10 by 10 is 100 square feet. So each square foot is 10,000 lumens on the moon. So 100 times 10,000 is 1,000,000. So that every 10 by 10 square like that would have 1,000,000 lumens in it. Crazy bright. 5 times brighter than this. I got this moon landing photo right from NASA. Let's rough in these 10 by 10 squares. And each one of these squares would have 1,000,000 lumens. This small area would be millions of lumens bright. Does the moon landing look like this?
Okay, cut.
Wow. Neil, so glad I caught you. I'm the head engineer on the Apollo mission. We did the calculations on the moon, and it's so bright. if you try to go up there with you and your men, you'll burn the eyes out of your head.
And with all solar winds.
I'm going to go with, let's take it a little farther. Here's my mock-up moon, a couple different colors. Okay, let's set up our moon here and shine a light on it. Okay, now you see how there's a little shiny spot in the middle? Now let's compare it to the real moon. The real moon is lit evenly all the way across. Even the edges look a little more, have more luminosity than the middle. So that doesn't make any sense right there. Now either maybe the moon's not a sphere, maybe the moon is flat, or is it possible the moon is giving off its own light? I say this because the sun is supposedly shining on the moon and reflecting back to the earth. Let's compare these two. On the left side, I have a regular light. On the right side is our mock-up moon, and I have a really bright light shining on it. Notice the shiny spot in the middle of it? Now, the one on the left, you can see it's a light. It gives off shimmers. The one on the right, you can tell it's just an object that's being lit up by another light. So it really doesn't match. Now watch the moon compared to a light. They both look very close. They both give off shimmers. You can tell it's an actual light, the moon. You can see that you're not looking at a dirty, dusty ball being lit up by the sun. I think the moon is not what you've been told. And I think we pretty much crushed the moon landing.